All right, let's get started. Welcome everyone to Integrated Runway Analysis and Weight and Balance. In this webinar, we are, as you might expect, going to cover ForeFlight's runway analysis and weight and balance features and how these are integrated into ForeFlight's flight planning workflow. As some of you might be aware, ForeFlight's runway analysis product has been available for several months since March of 2021. But the weight and balance capability is something new that we're adding. And essentially, we are upgrading ForeFlight's previous weight and balance capability, which was essentially a standalone weight and balance calculator, and we're turning that into something that is fully integrated with your flight planning. And so that is something that will become available very, very soon, possibly as early as next week, actually. And it will be available for business performance and MFB performance customers. It will also eventually become available for individual Performance Plus subscribers later this year. And so in this webinar, we'll take a look at how that new capability really enhances ForeFlight's already very highly integrated flight planning and turns it into something where ForeFlight is just a one-stop shop for all of these aspects of your flight planning workflow. Our participants in this webinar are Alex Smythers. And Alex, if you can go ahead and introduce yourself.
Yeah, thanks, Sam. Hey, folks. Alex Smythers here, leading business development efforts and managing strategic relationships for ForeFlight. I joined the team in 2019 and pretty immediately started working with the major business jet OEMs to procure a reliable source of approved performance data for all of the business jets out there. Had a trip to Montreal and a trip to Wichita before the global pandemic put a damper on things, but I'm happy to report that we have established relationships with most of the major players out there. And the team has done some pretty amazing work in creating these new capabilities for us. Over to you, Michael.
Thanks, Alex. My name is Michael Vogt. I'm the aircraft performance engineer at ForeFlight. I've been an aircraft performance engineer for over 22 years now, starting off with Cessna flight test back in the day. I've always enjoyed the nexus between software and aircraft performance data, and I kind of continue that now at ForeFlight, and I've been here since 2015. Josh?
Thanks, Michael. I'm Josh Pava. I'm the quality assurance representative for ForeFlight Dispatch. I've also been pretty heavily involved in our weight and balance and runway analysis design and specifications. And I'm hoping to add some context today in real-world scenarios that I use while I fly my Challenger 605, which I manage out of the California, San Diego area.
Awesome. Thanks, everyone. So moving on to the agenda for today, we're going to start out with a very high-level look at why runway analysis matters. And this should be a fairly obvious question for any pilot who's listening, but we especially want to focus on how the integrated capabilities that ForeFlight offers in regards to runway analysis and weight and balance can really reduce the risk of error and improve your operational safety when you have all of these capabilities integrated together. Following that, we're going to move on to a live demo of this integrated workflow, going from start to finish with creating a new weight and balance profile using the new weight and balance paradigm, which includes the ability to specify certain items in your basic operating weight setup. And that's a crucial new capability that we just introduced. Following that, we'll do some flight planning with the integrated weight and balance capability, and then moving on to the runway analysis planning. So just showing how you can go from start to finish with these integrated capabilities and come out with a much more efficient flight planning workflow. Following that, we'll have a quick wrap up and then move on to Q&A. So before we begin, you can ask questions via the GoToWebinar message panel. You just click that button with the question mark on the right. It'll open up that panel and you can submit questions in the text field at the bottom. We will respond to as many questions as we can whenever you submit them, and we'll pick a few of those to answer live at the end during Q&A. We do recommend that you submit questions whenever you think of them. Don't wait until you see the Q&A pop up on your screen because there's a good chance your question won't be answered if you submit it that late. We do recommend that you always join from a computer to watch these webinars, not a mobile device. We find that people who join from mobile devices like iPhones and iPads often experience audio problems. So just a general recommendation for any of these. If you are having audio problems or for any reason you need to leave early or you have a friend who wanted to watch this webinar and couldn't make it, it will be available for viewing at foreflight.com/onfrequency in the next few days. So with that, I'm going to hand it over to Alex to take us through some of the high-level values and capabilities of runway analysis in ForeFlight.
All right, thanks, Sam. The first point here is that we've built a fully integrated solution from the ground up. We built our own proprietary engine for field performance calculations, which has given us tremendous flexibility in our implementation. With that, we've tightly integrated the Runway Analysis solution into the flight's view. And the great thing about that is that as you're updating your passenger details, cargo, and fuel parameters for your flight plan, we're automatically passing that information into the Runway Analysis takeoff and landing calculations. We've also got some savvy tools that are automatically pulling forecast and actual weather conditions based on the time of departure and time of arrival, and automatically running calculations for multiple runways, resulting in our ability to automatically suggest the best possible maximum takeoff weight and landing weight, runway and engine out procedure where applicable. It's easy to change weather and runway conditions and aircraft configuration to recompute takeoff or landing performance before departure at top of descent. We also have Runway Analysis tightly integrated into our dispatch product, where again we're able to make those suggestions as a part of the flight planning process. The third point here is that our aircraft performance data is sourced directly from the aircraft manufacturers, and we'll get into that into more detail here in just a minute. We've also created our own tech for designing engine out procedures, which has helped us to build over 5,000 of our own procedures at this point, with more coming all the time. This results in our ability to suggest the highest possible maximum takeoff weight, given the limitations imposed by surrounding terrain and obstacles. A description of engine out procedures is included in the takeoff view, along with a visual representation on the map, which you guys will see here in just a few minutes. So why are we doing this? Well, at ForeFlight, everything we do has a focus on improving the safe operation of flight. We understood pretty early on that we could automate much of the takeoff and landing calculations by, again, leveraging weather data and flight planning calculations, things that we already had in the app. With a simplified process and easy-to-use UI, our hope is that our solution empowers more pilots to better understand the limitations of their aircraft and improve the likelihood of a safe outcome for every takeoff and landing. In order to produce these calculations, we need data, and for that we went straight to the source. Again, over the last few years, we've cultivated relationships with the major business jet OEMs in order to secure a steady supply of approved aircraft performance data. Typically, that's the same data as what the OEM is using in their own performance applications, and the format varies between the OEMs, from that which is found in the AFMs to tabular data sets that typically feed the charts and tables in the AFMs, to SCAP modules and other sorts, which Michael's team then standardizes into a format that we can use within the ForeFlight applications. You'll see here that we support a number of Bombardier, Embraer, Gulfstream, Pilatus, and Textron models today, and the team is working hard to support more aircraft every month. So definitely keep an eye on foreflight.com/RWA, and there's a place there for you to subscribe where you can receive notifications when we release new tranches of aircraft. And now I'll turn it over to Michael.
Thanks, Alex. We launched Runway Analysis for Jets in March of this year, 2021. And in September of this year, we are launching Weight and Balance, fully integrated, as well as supporting jets. And right off the bat, we are supporting about 70 business jets for runway analysis and about 80 to 85 business jets for Weight and Balance, in addition to the over 200 pistons and turboprop aircraft for Weight and Balance as well. One other thing we're doing is we are creating, in context with our engine out, or with our runway analysis, we are creating our own engine out procedures. So these are custom engine out procedures, and we currently support about 5,000 of those, and that grows every single day. So on the next slide, we can see that where we're at right now is this year. We support Part 23 and 25 certified aircraft. So this goes anywhere from a Cessna 172 all the way to a Gulfstream G650. We provide full fidelity Enroute performance models. We model those with multiple altitudes, multiple temperatures, multiple weights, and some other powerful capabilities to make sure that you have cruise capability when you get to altitude. We have a global flight planning engine. We have runway analysis with our custom design engine out procedures. And in terms of operations, we support 91, 91K, 135 operations. And technically, we also support 121 airline operations, even though as of this point, we do have no intentions of supporting those types of aircraft with runway analysis. On the next slide here, I want to talk a little bit about integration. So the key is integration. The whole point of this is to integrate the Enroute flight planning with the weight and balance with the runway analysis. And we want to make sure that any flight you plan has sufficient fuel to get from point A to B, and also your alternates, of course. We want to make sure that takeoff, landing, and throughout the flight, you're always within CG parameters. And we also make sure you fit on the runway, either taking off or landing. So that's where the runway analysis portion comes into play. Furthermore, we realize that pilots have different workflows. Some pilots like to do weight and balance before runway analysis. Other pilots like to do it the other way around. So we've set up a system where you can choose your workflow and work with your workflow that's most comfortable to you. And finally, we support this not just on an iPad or a web browser on your laptop or desktop, but also on the iPhone. So the power of these three items combined and integrated together, you can access on your iPhone on the fly as you have to make changes last minute before you take off. So it's a very powerful solution in your hand. Okay, with that, let's get into an actual demo here. So the flight today I'm going to demo is from KEGE, which is Eel County in Colorado, and we're going to fly down to Key West in the Challenger 300. So I'm going to go through the four main steps here: aircraft setup first, then I'm going to switch over to route planning, followed by weight and balance, and finally the runway analysis. Let's start with aircraft setup first. Okay, there we go. All right, so this is the route shown on the map, as I previously showed in the screenshot before. And the first step I want to do is I want to go to the lower right corner and tap on the More tab, which currently has this badge with 25 downloads waiting for me. So when I tap on the More tab, I have a menu here and I want to set up a new aircraft. So I will tap on the aircraft button, third from the top. This brings me to a setup here where I can tap on the plus sign, which is in the upper left corner there, to add a new aircraft. So once I do that, I'm greeted with this screen here. And the important thing to see are the two orange items, tail number and aircraft type. So these are the two required fields to set. I will type in a tail number of some sort here. Let's call it 300CL. And then I'll tap on aircraft type, and it brings me to a search interface where I can input my ICAO code for the Challenger 300. Now in this case, we have two variants here. They differ with maximum takeoff weight, but only the bottom one supports runway analysis and has weight and balance templates available, which is clearly shown with these blue lines here. So that is what I'm going to select. So with that aircraft chosen, the aircraft is more or less set up for me. I'm going to have to dive into the weight and balance and do a couple more other things, but right now I have my Enroute Profiles configured, which I can, in the performance section here, there's that group performance. I can tap on Performance Profiles, and I can see all the Enroute profiles that are available to me. Now, some aircraft support multiple climb or multiple descent profiles. In this case, we only have one of each. And if you want to, you can actually, if I tap on the 250 KIS and Mach 7.5 climb profile, I can actually go in there and now bias it with time or fuel for the climb, which is important if you maybe fly into the New York City area, or really on the descent profile, it's important if you fly into the New York City area and you know they bring it down earlier, maybe you want to add some extra fuel in here. So that exists now as of very recently. And the other thing I do here is I can actually set a default cruise profile. So if I tap on the cruise profile, Mach 0.8, for example, that very bottom button, make default. So I can tap on that. If that's my preferred cruise profile, I will set that as a default. Going back 2 steps, just below the performance profiles, I have a runway profile. Now, normally there's only one option here, and in this case, there's only one option here, but some aircraft, especially on the piston side, you might have different serial number ranges, resulting in different aircraft performance, and then you will see a list here of the one to choose for your aircraft. The one below that is field performance, and this is actually very important. If I tap on field performance, what this view allows me to do is it allows me to set my default aircraft configuration, which will show up on every single flight that I create. So when we create the models, we typically try to set some defaults based on the AFM guidance, and we do that. But maybe you don't always take off flaps 10, maybe you prefer to take off flaps 20 or something like that. So you could tap on that and simply change it to a different value. And then every new flight you create will use that new default value. 2 things I want to point out here. The first one is on takeoff. In the very bottom of the takeoff group, we have obstacle corridor. So when we create the engine out procedures, these are custom engine out procedures that we create. We follow AC 120-91 alpha, which is the FAA guidance on the airport's obstacle accountability area. And it prescribes a very specific corridor to look for obstacles, and I'll show more on that later. But we also support ICAO versions. So there are 2 different versions, FAA and ICAO. The ICAO corridor is slightly wider and some other slight different changes. But if you're running an operation that is not an NTEL registered aircraft, you probably want to switch over to the ICAO corridor definition. And that way, that corridor definition for the obstacles is used with every takeoff analysis. The other thing I want to show is at the very bottom, landing factor. So the default landing factor is 1.0 that we have set, and these are for factored landing distances. Many operations will actually set a different factor for their operations, and we list a few of the popular ones here. So the bottom two are for a 60% dry and wet factor. The middle two are for an 80% dry and wet factor. But many operations will default to the 15% even with dry. So I'm going to go ahead and set that to 15% default here. So be sure you go into this area, this field performance screen, and make sure you set the defaults that you want to have for your operation. So with that out of the way, I'm going to scroll down a little further. We have a weights block here. All the weights are already pre-configured for you for your aircraft. You definitely want to double check that these numbers match the ones that you expect for your aircraft. But what I want to do next is set up a weight and balance profile. So if I tap on the green button, weight and balance profile, I see this dialog here. Now there are two groups. The top one says from templates. The bottom one is a migration one. I'm not going to talk about the migration group or anything, how that works. But really what it is I have some older aircraft that I previously set up in weight and balance, and I can migrate those over to the new weight and balance setup by selecting one of the bottom profiles there. But instead I want to focus on the top one, the from templates. So the aircraft performance group, we build weight and balance templates for you to quickly get started with your weight and balance setup. Now you always have the option to build your own from scratch, which is that blank template, that second option there. If you select that one, you need to crank open your weight and balance manual, and you're going to have to type in a lot of information yourself to set it up. We try to take that and do that for you. So this aircraft has in the weight and balance manual a single configuration defined. It's called the double club seating arrangement. And we went ahead and created a template for you that includes all the information from that layout configuration given in the weight and balance manual. Once again, we're using these orange or gold font items to convey to you which inputs are absolutely required. So in this case, we must provide a basic empty CG and a basic empty weight. Now, this will change from aircraft to aircraft, and it's going to be specific to your tail. So you're going to have to find your load sheet and be sure you input the correct CG and empty weight here. Now, for demo purposes, I'm going to use 605.1. And we're going to go with 23,200. And that's really it. So I've just configured my entire weight and balance for this aircraft. However, it is extremely important that you go through all the station definitions here. As you can see, each station has its own arm value prescribed. And this comes from the weight and balance manual that we have access to, but it may or may not match the stations for your aircraft. So it's very important that you go through and configure the stations as needed. Now, the way this screen here is built, we have a group of stations, and these stations use iconography to show, is it a row of seats, is it a single seat, or in case of these four squares, it's more of an aircraft item, we call that. And then if I scroll further down, we also have the tail compartment has its own cargo icon, and then of course the fuel tanks has its own icon as well. And I'll dive into these here in a second, but I want to first show a little further down here, we have the forward and aft CG limits prescribed here. So the nice thing about this is the blue font means they're editable. So I can tap on any of these values and change them. And why that is nice is because certain operations might curtail their envelope. So if you want to use standard weights, for example, and standard weights you can actually define in settings as well. So you can set a male standard weight as 200 pounds if you want. You can set a child standard weight as 80 pounds if you want, and so on and so forth. But if you want to use standard weights for your operations and therefore curtail the envelope, you can come in here and do that yourself. Now, we don't calculate the curtailment for you. That's something you need to do yourself, but you have full control over this section here in terms of changing these values. And on the flip side, if you're running an operation and also you have the account set up with an administrator, the administrator will then control the settings here, but then can lock these away from the crews, because the administrator in that case can define how each aircraft is set up. Obviously the crews, we don't want them changing that once it's set in stone. So there's a lot of flexibility here. Finally, a lot of aircraft, they do prefer to use percent MAC, mean aerodynamic chord. So you can toggle this on with percent MAC, and then all the station arms will be shown in percent MAC as well as on the plot. So let me dive into one of these stations, for example, flight deck here. So this is the cockpit crew, of course, and one thing that we now have included is support for basic operating weight. So on the flight deck, I will always have two pilots in this case because this is an aircraft that requires two pilots. I can tap on the pilot row here, and I can say I want to include the pilot into basic operating weight, and I want to set that weight at 190 pounds. When I back out, I'll now see a BOW badge, and that BOW badge there shows me the pilot is included in the basic operating weight calculations. And I will do the same for the co-pilot. And Josh, do you have any, I'm kind of curious if you have anything to add from operator's point of view while I go through here instead of a few more basic operating weight items to make the scenario a little more realistic?
Yeah, sure, Michael. So I've actually set up the aircraft that I fly with an aircraft profile like Michael is showing us here. And as we had talked about, what I did is I went through our weight and balance manual and added some stations, or in some cases removed some stations that were not applicable to my aircraft, and then individually chose which I wanted in BOW, which I didn't want in BOW. And I found that to be basically something that really brought the whole weight and balance product together from our previous weight and balance solution. This is essentially a top to bottom takeoff to landing solution with where you add passenger weights, add baggage weights, and you're pretty much ready to go.
It's always good to hear how this is used in the real world. One thing I do want to point out is that every station has a notes block. So this, for example, on the cargo compartments, you might have a loading restriction, X amount of pounds per square inch or something like that. And we provide a notes block here that you can add that information in so that it is then visible later on to the pilots to remind them to jog their memory. There's also some weight limits in there that you can set if you wish to. And of course, you have full control over the naming as well. But really, in these 2-3 minutes, the entire weight and balance section was set up and we're done with that now. So we can actually take this aircraft and go plan now, which is exactly what I'm going to do. So I'm going to switch over to the flights tab. And at the bottom here, we're on the aircraft tab right now. So if I tap on the flights tab, it's going to take me to the flights tab. And once again, as with the aircraft setup in the upper left corner, I have a plus sign. So I'm going to add a new flight by tapping on that plus sign. And it's very simple. I define my departure airport, my destination airport. If I want to define an alternate, I do that as well. And I already have an aircraft selected here, the one that we actually just set up. So I'm going to type in, or really pre-select here, Eagle County. And we're going to go to Key West. And it's going to tell me, I have to update my flight level to 410 for performance reasons. So I'm going to go ahead and accept that. And right away at the very top, you see our header. It already pre-calculated a direct flight from Eagle County to Key West, almost 1,600 nautical miles, 3 hours and 15 minutes, and about 6,400 pounds of fuel with that tailwind given there. So very quickly, we already have our first calculation results here. I can select different performance profiles, as I mentioned earlier. Now, these are selected for me, and basically I can go here and make changes if I want to, which I will not in this case. Scrolling further down, I have a map here. It's a direct routes. And if I tap on the routes button there, it's going to bring up our route advisor. And the route advisor will go through and find both a recommended route, which is often an optimum route with wind and ATC considerations that day, and provide that as a recommendation. We also show a preferred and ATC cleared routes, for example. Josh, I know you use this every day on every flight. What's your experience with regarding the recommended route?
So the recommended route is typically optimized, as Michael said, both for time, fuel, and ATC considerations. I have a very, very high success rate with the recommended route. Probably out of 100 flights, I would say 98 are cleared as filed from the recommended route. I find it works really well, and it's realistic for what we can expect when we go flying, which helps when we're calculating all this data, for fuel planning, performance planning, runway analysis, that sort of thing, to know how much fuel am I really going to need and how heavy can I depart a specific airport, because I know I can count on that data that I'm being shown.
Yeah, that's great. And as I mentioned, we recently introduced biasing of climb and fuel, climb and descent, fuel and time. And that was a piece that was missing because some operators, have mentioned they'd like to have that ability. So with that ability in place now, I think they can even further refine the flight planning, fuel and time capabilities. So I'm very much looking forward to hearing back some feedback from that implementation there. So moving along.
Yeah, and actually, Michael, on that, I think it's worth noting, as you imply, I use ForeFlight for all of my flight planning between ForeFlight Dispatch, ForeFlight Mobile. And I routinely do flights, 2,000, 2,500 mile flights that are accurate within 1 to 2 minutes and 50 pounds of fuel. Just yesterday, I did a flight that was 2 hours long. I was right on the time and 10 pounds off on fuel. So these are some numbers that are pretty profound and pretty amazing that we can flight plan with that level of accuracy. And this isn't a Challenger 605. So, the trip length of 2 hours is burning around 5,000 pounds of fuel. So we're talking, well under 1%, margin of error on a flight like that that's burning 5,000 pounds. So pretty impressive.
Yeah, that's all awesome. I love it when you send me emails to say, hey, this last flight was that accurate because, I know we're doing something right here, which is great. Of course, it requires you to fly the exact speeds that we model as well, which is important, of course. But that's awesome. That's great feedback. Okay, I want to talk next about the weight and balance. We're going to set up a weight and balance scenario here. And in the center of the screen, you see payload. And the payload view that you see now is what we've always had. You can add people here with an average weight and move on and not dive into the weight and balance section if you want to. However, if you tap on the weight and balance button, you can now dive into that. And we already have our double club seating arrangement configured. We already have our basic operating weights included here. So we have our seat section. If I scroll further down, we're going to have our cargo section, which is currently empty. And then in the aircraft items, we have a few items that are part of the basic operating weight. And those items have a gray number on the right side, which means you cannot edit them here. And that's kind of the point of basic operating weight. You set it once and then forget it. On the top, you see, once again, a header. So left to right, we have our basic operating weight, zero fuel weight, takeoff weight, landing weight for this flight. And then, of course, we have the graph representation here. So you can two-finger zoom in on here. We show the takeoff weight and then the fuel burn throughout the flight to the landing weight. And then, of course, we show the rest of the fuel burn all the way to zero fuel weight. If I were to go in here and maybe add 1,000 pounds to this seat, the idea here is to basically get it to error out. It's going to show me that my takeoff CG is too far forward. I get this nice red shaded envelope to say, hey, visually something is wrong here. Something has to be fixed. And I can see right away my takeoff weight point is indicated red because it's forward of the CG limit. So obviously we check all these as you input your information here. So I'm going to clear this out to bring it back within CG bounds. And what I'm going to do then is I'm going to load a few items up. So when you tap on it, we have a quick entry mode with standard weights. And as I mentioned before, you can go into the settings tab under the more section and define your standard weights for male, female, and child. And we currently have those values set. So I can very quickly load a male here, for example, and then female there. We also track any kind of named loads that you have. So on the bottom, we have saved loads. And I created a load previously with 130 pounds. I provided the name of name, which is not very wise, but you can provide actual, first, last names here if you want to, if you have certain people that you fly with all the time. And ForeFlight will remember those items, those people, and provide them in the save load section for you. So let's throw some cargo in here as well, maybe 250 pounds. And every time I do this, it is updating the graph, of course. So we kind of shifted the CG forward now because I've added some people into the seats. But that's what we have here in terms of weight and balance. Everything's computing real time, updating automatically. So once we're back on the flights page, the weight and balance setup that we have just created is reflected here under the payload section in far greater detail than we had before. We again show the basic operating weight items. They're still grayed out. However, I can change the loads, the seats that I have set loads for in this case because they have blue font. I can quickly tap on the 6 empty seat row there towards the bottom if I want to jump right back into my weight and balance setup section to add more people. But I can also clean this view up by collapsing the people section. So each item here is collapsible to retain that clean look essentially. And I can of course expand it here too if I want to take a peek at some details. The weight and balance line has this imbalance in green, which is a quick check for you to ensure that your setup is currently in balance. Obviously, if you're outside of balance, it will turn red and give the appropriate warning as well. But very quickly, I was able to add a few people to the weight and balance manifest. Essentially, it does all the calculations for me. It tells me I'm currently in balance. And then if I scroll further down here to the weight section, it's going to give me my weight overview. So my zero fuel weight, ramp weight, takeoff weight, landing weight as before. Now, one thing I want to do here is I want to go to the fuel section here. We have a concept of fuel policies, and by default, we use a minimum fuel required policy, which is enough fuel to get you from point A to point B plus your reserves, but no more. And that's a great way to start your planning. Sometimes you want to add some extra fuel for one reason or another, and there are many different ways you can do that. In this scenario, let's say we're going to drop our passengers off at Key West and fly on to West Palm Beach or something like that. So I want to actually bring more fuel along. Now, what I want to do is I want to land in Key West with 4,000 pounds of fuel. So on the fuel at landing line, on the far right, I have 1,430 pounds currently predicted to have in my tanks when I land there. So if I simply tap on that number and change that to 4,000, I very quickly change from a minimum fuel required fuel policy to a landing fuel policy. So we do the calculations for you to determine how much fuel you have to upload. In this case, it's going to be 11,315 pounds so that I can land at Key West with 4,000 pounds in the tank, drop passengers off, and then take a short flight over to West Palm Beach, for example. So the fuel policies are very powerful. Definitely recommend exploring those. Josh, you probably use them a lot more. I know we have this reserve fuel policy button here that does some additional things. Do you want to talk anything towards that?
Yeah, I definitely use the fuel policies basically on every flight. Much like Michael demonstrated, my typical policy that I use is landing fuel. However, as the situation dictates, I may say manual fuel in minutes or one of the other policies. For the most part, the screen we're showing here with reserve fuel policies are essentially what covers most of the operations that we flight plan for. So for Part 91, 135, it's essentially going to be planning a 45-minute reserve at your top of descent. For Part 121, we do very similarly. It's also 45 minutes, but it's compliant with the 121 regulations. And as we continue on down with Part 121 International, EASA, General Aviation, EASA Commercial, those are all profiles and policies that we support with explanations below each of them. What I think is worth pointing out in the flight view, Michael, if you don't mind going back to that, is that when we manually input fuel, whether it triggers a landing fuel policy or a manual policy, if you wanted, say, 12,000 pounds of fuel, we're also checking to make sure that the weight and balance is going to stay within the envelope. And if you are using a runway analysis with the aircraft, that the field that you're planning to depart from supports that weight for departure as well. So the flight view, as is being shown on the screen here, is sort of your one-stop shop for telling us, do you have enough fuel to get to your destination? How much fuel are you landing with? Are you able to depart from the runway that you're leaving from? Are you able to land from the runway you're going to be landing on? In other words, do you have enough fuel? Are you under max landing weight? Those sort of considerations. Plus, of course, where does my weight and balance lie during takeoff, cruise, and landing? So the flight's view, as I use it, is sort of your central point for getting all this information in one place. Very handy view. And like I say, it's where I do the vast majority of my flight planning, and where I'm looking for any issues that it might have with the flight. It's going to be right here in the flight's view.
Yeah, it's a great detail. Also a great segue into runway analysis because indeed, I'm going to scroll to the top here. Indeed, the runway analysis portion is part of this triangle I showed earlier. And again, it is cross-checked against the weight and balance portion. It's cross-checked against the available fuel for the flight planning portion. So now that we have our flight plan set, we have our route set, we have the passengers and cargo loaded, we want to make sure we can actually take off out of Eagle and land in Key West. So I scroll to the very top here, which I already did. Departure airport line has a takeoff button. So when I tap on that takeoff button, it takes me to the takeoff view. Now, right off the bat here, we actually have no calculation. And what we need to do at first is we have to select a runway. But before I do that, I want to kind of step a little bit through what we're looking at here. At the very top, we have what we call a header. And the header is the area that we show all the critical information. It is static, so when I scroll here, it doesn't move. Because you will see here your V1, VR, V2 speeds. You're going to see your takeoff field length, your level off altitude for the engine out, initial level off altitude, but also that second line there, the maximum takeoff weight, currently 38,850 pounds. And the reason we're limited is because we have reached our structural weight limit. So when I tap on runway, where it says none, I'm given the option of 2 runways here. And I'm looking at the METAR below. I see 0 knot wind. This is the reason why a runway is not chosen for us. Normally, if you plan a flight and a current METAR is present and there's some wind present, we will actually pick the suitable runway for you. But in this case, it's a calm day out in Eagle County, so I'm going to pick my runway myself. In this case, I'm going to pick runway 25. Before I do that, I can tap on the details button on the far right, and it will give me some additional information about that runway in case I want to learn more about it. Basically, I even have a way to pull up some procedures in the bottom there. But let's pick runway 25. And it's going to go ahead and tell me, hey, takeoff's impossible due to obstacles. Now, if you've ever been to Eagle County and you're looking off of runway 25 towards the west there, you'll see that immediately, just within 3 nautical miles of the departure end of the runway, the terrain goes up by 1,500, 2,000 feet right off the bat. So we are currently configured for a straight out departure. And we see that we have these 2 groups here. We have a departure runway group where we're showing information about the runway. Below that, we have an obstacle analysis group. And the engine out procedure selected right now is straight out. So what I'm going to do here is I have the option to tap on that, and it's going to pull up our engine out procedure advisor. Now, as I mentioned previously, we have designed in-house over 5,000 engine out procedures, and that number is growing daily. And we have obviously covered most of the mountainous airports by this point. So what we have defined in this case for Eagle County is EOP1. It's an RNAV, engine out procedure. And it shows me right away my maximum takeoff weight choosing that procedure is 37,100 pounds. So if I tap on that, I see in the map what the procedure looks like, and I can actually zoom in on this as well. So this procedure is actually modeled off of the Beaver SID out of Eagle County, and it uses the exact same waypoints. We do this on purpose, and Josh, you can talk a little more about that, but we do this on purpose because it simplifies the pilot's workload. Probably actually a good point for you to jump in on that. So why don't you tell us a little bit about how useful it can be if our engine out procedures that we design do follow SID or partially follow SID from your point of view as a pilot?
Yeah, thanks, Michael. I think one of the issues that we as pilots have with runway analysis is at times they diverge greatly from our cleared route. So there's always the question of, I'm at 300 feet, I've started to join this RNAV departure, and I have an engine failure. What do I do now? And if you're not following the departure procedure that you're cleared on in your engine out procedure that you've selected, it sort of gives you a gray area of how do I get from where I am on this departure procedure to where I want to be. It's not a good situation. It's certainly one that I try to avoid as a pilot. And so that's why on some of these engine out procedures, you'll see RNAV1 or EOP1 RNAV, EOP2 RNAV. And the majority of the time, as closely as possible, we're trying to at least match the first few fixes of the departure procedure such that if you do lose an engine after takeoff while you're on a published procedure, you can easily switch over to the engine out procedure. So whenever possible and whenever it makes sense, we closely match the EOPs that we're producing with the published procedures. And again, it's simply for the reason of how do I transition onto it? Well, if you're already on the same exact procedure, it's a seamless transition.
Yeah, it's a great insight, and I appreciate that. So what I want to show real quick is take a pause here and look behind the scenes on our engine out procedure design. So in-house, we have developed some sophisticated software to help us design engine out procedures for when you lose an engine during takeoff. And remember, this is a scenario where you're taking off and just prior to reaching V1, you lose your engine, yet you have decided to go instead of stop. So now you're climbing at V2, you're pitching for V2, and you have to follow this lateral track that we have designed. Along that lateral track, we use the AC 120-91A guidance for the FAA corridor, or the ICAO guidance for the ICAO corridor width, which you can kind of see in the screenshot as this blue corridor overlaid on the terrain. This is actually the exact same Eagle County Runway 25 EOP1 that we have designed. And within that corridor, we're looking for all the obstacles and all the terrain that will impact our flight. We then essentially throw the aircraft climb performance, single engine climb performance against all those obstacles and the terrain within that corridor. And we ensure that the chosen maximum takeoff weight that we provide as a solution will clear all those along the net flight path, just as it should per the AFM requirements. And we typically end up these procedures in the holding pattern, which is indicated in yellow here. And below that screenshot, you will see the vertical profile for this particular one here. Again, some additional tooling that provides us to decide if the engine out procedure is good or not. And something else we do with this tool is we actually have a few pre-configured aircraft in there, and we do the calculation for each one. We do the maximum takeoff weight calculation for each one, and it provides us a metric to determine if the designed engine out procedure is actually a useful and viable one in terms of trying to maximize that maximum takeoff weight. Now, Josh, I'm going to bring you back in here because you had some recent experience on your recurrency training, specifically with this departure here out of Eagle County, Runway 25. You want to talk about it?
Yeah, I definitely did. But before we jump into that, Michael, what I want to say is I've been involved with the design of these procedures basically since day one of our project at ForeFlight. And one notable fact here is that these procedures are not theoretical procedures that are complex to fly and, maybe a pilot can identify this. We're really going for ease of identification. So we've all done runway analysis procedures that say, go to the ABC 123 degree radial at 12 DME and then turn right and do a 25 degree bank and keep it within the 175 degree radial. And I think we could pretty much all agree that when it comes to actually flying these procedures in the real world on a single engine, that's going to be a pretty tough procedure to follow. So most of our procedures are RNAV based, and they're checked for reality as well. Can I really fly this procedure? Can I load this procedure in my FMS? Is there an easy way to load this? Or does it require significant skill or knowledge to fly this and execute it properly? So when we design these procedures, they're designed to be as simple as possible and as flyable as possible. As Michael said, recently I went to recurrent training on the Challenger, and I decided to try our EOPs out of Eagle in the simulator at maximum weight, both off runway 7 and runway 25. And I think the way that I would sum up what I saw, we had it in VMC so we could see what it looked like relative to terrain, was the procedure worked phenomenally. It far exceeded my expectations as far as how easy it was to fly the procedure and how well it worked. So if before I was saying, I think this procedure will work, but you have to be just extraordinary to make it work. It's really not true. If you simply follow the EOP and you do what it says to do and you hold the proper speeds, you end up right where you're supposed to end up. How you're supposed to end up relative to terrain clearance works phenomenally. So I think my takeaway from the entire experience was brief the procedure before you take off, know what you're going to do if you lose an engine, know how you're going to transition over to the EOP, and simply follow the text description, and the EOPs worked phenomenally. It was a pretty eye-opening experience to see just how well choreographed it can be when you take the time to fly exactly as the EOP tells us to do.
Yeah, that was great feedback when you provide that to the team. It's a validation point, at least for Eagle County, that the chosen design is appropriate, as well as the aircraft performance model that is used with that, for your particular aircraft. So that was fantastic to see. Made me happy. Appreciate that insight there. So if we can switch back to the iPad, I'm going to continue with the runway analysis portion. So in this case, we choose EOP1. And as Josh alluded, we have the instructions here on how to fly this. We try to keep them as simple as possible. There might be some speed restrictions here and there, especially in the holding pattern, which we also list. So I'm going to tap on the EOP1. So what we now have, if you look up at the header, we now have an actual calculation of performance. So that maximum takeoff weight line tells me 37,099 pounds. And the reason I'm limited is because I'm obstacle limited. We were able to go from a previous limitation of about 30,000 pounds on the straight out to 37,000 pounds, giving us a lot of additional capability here simply by choosing this engine out procedure that we have designed. It also shows me now for my planned takeoff weight of 35,600 pounds, my takeoff field length is about 6,100 feet. I have my V1, VR, V2, as well as my VFTO speeds listed there, and also my level off altitude. And the level off altitude is an MSL altitude that the pilot targets so that you pitch V2 and you maintain that V2 speed until you reach, in this case, about 9420 feet, and then you level off, which will keep you clear of all the obstacles. And you simply continue into your holding pattern there, or you contact tower and get routed somewhere else in that case. So under the obstacle analysis block, you also have the ability to add additional departure obstacles. What we do is we scan the NOTAMs, of course, and we include those into our obstacle databases. But if for some reason there's a brand new obstacle tower or something like that, you have the ability to add an obstacle here by defining the distance from the departure end of the runway, as well as the height above the departure end of the runway, and it will be included in the analysis as well. So that exists. Real quick on the departure runway group, the one right above it, where we have our runway listed. Right now, there's a usable length of 9,000 feet. If the runway includes declared distances of some kind, it will actually break them out with the TORA and the TODA and the individual runway lengths there. So for this particular runway, they're all 9,000 feet, so we just simplify that to usable length. The lineup allowance is really intended for larger aircraft. That's when you take the active runway from the taxiway and you do that 90 degree or maybe even 180 degree turn or whatever. How much distance do you lose by lining up? So if you fly to the Gulfstream, you typically lose, I think, 100 feet or something like that. So you can put in 100 feet there, and it will always, subtract the 100 feet behind you as non-usable runway length. So we have the ability to do that there as well. The surface condition, it will vary greatly from airplane to airplane and even within the configuration. So in this case, certain configurations are not possible, but basically they are listed here, and you can select your surface condition. The performance data comes straight out of the AFM. So you want to consult your AFM in terms of what you're dealing with for this particular aircraft. Scrolling down a little bit, we have a weather block. It's very much what you expect. We load a METAR if your departure, I believe, is within 80 minutes if your planned departure time is within 80 minutes of now, essentially, and there is a valid METAR, we load that first. Otherwise, if it's out in the future, we're going to load the TAF. If you're in the United States, eventually the MOS. And then at some point, we switch over to our daily weather information if you're planning days in advance. But you can overwrite all these inputs as well. Obviously, you probably want to do that as you're taxiing to the runway to get the latest wind information, if nothing else. The aircraft configuration section, it is, once again, specific to an aircraft. This is a Challenger 300, so we have these options here. And once again, as I showed at the very beginning, you can actually set your desired defaults so that they always show up here as well. Emergency return, this is essentially a landing view. So if I tap on here, I go into the landing section more or less. But the one thing is the emergency return allows you to do a landing performance calculation, which includes the ability to plan for an overweight landing. So this is the one area where you can plan a landing above your maximum landing weight, your maximum structural landing weight, in case you have to do that for emergency. I'm not going to go into it because we'll cover landing here shortly. And then after that, we have a performance output block. So this is additional information to the one you already see in the header. It goes in a little more detail. So for example, we're showing the reference climb gradient of 4.4% here. We're showing we have a transition speed where I believe the flap retraction happens for this aircraft. And then we also have an en route net climb gradient at level off altitude, in this case of 3.2%. So this will vary from aircraft to aircraft, but there's additional performance data shown that we cannot put up in the header. And then finally, we have our engine out procedure listed here in textual format as well. It's just there for reference, basically. Okay, that really covers the takeoff view. So I'm going to go back one level to flights by tapping on the left pointing arrow, KEGE to KEYW. And that brings me back into flights. And just below the departure line, I have my destination airport, and there's a landing button there. So I'm going to tap on the landing button to bring me into the landing view. Now, the flow, the layout is very much the same as we have on takeoff. We have a header here. In this case, I do have some wind information from the TAF. The TAF is shown towards the bottom of the screen, and it shows that runway 27 is preferred because it provides me a 4-knot headwind in this case. So because that runway is automatically selected, all my performance calculations are already here. So I have a landing weight of about 28,450 pounds. The actual dry landing distance in this case is 2366 with an approach speed of 120 and a reference speed of 114. It also shows me my maximum landing weight is structurally limited at 33,750. Now, the destination runway block, once again, has all the same runway information. We provide LDA here. The one thing I want to talk about is the surface condition as well as the landing factor. So we're currently showing the dry, non-factored distance, the actual landing distance, and you see in the header it says actual landing distance. If I want to factor that, I can choose my factor here. So I previously mentioned many operators, they will choose a 15% factor all the time for dry. And by choosing a factor, the header now shows me a factor distance. So it's kind of telling me, am I using actual or factored in this case? So that's one important key to note. Obviously, the whole discussion these days around the landing time of arrival, performance calculations that are required either at top of descent or during descent, all this is possible within ForeFlight because ForeFlight is 100% offline capable. So, as you're descending, you can come in here and update this as needed. Maybe you're going to have a different contaminant to deal with or something like that. Maybe you have a wet runway because a shower just came through or something like that. So I'm switching now to the actual wet runway, which is factored by 15%. If you want to do a true, 60% factor distance, for example, that's wet, what you would do is you would actually select the dry here and then a 1.92 to get your 60% wet factor distance here as well. So it's important to realize when you're selecting wet, most of the time, the wet information all of the time, it comes straight out of the AFM. So you're going to have to consult your AFM to understand if you're dealing with an actual wet distance or a factored wet distance. We basically model what's in the AFM, and I believe in this case, it's going to be an actual wet distance. So keep that in mind that you may have to have a different setup here depending on if you're dealing with a 60% factored or if you're allowed to use actual wet distance data.
I think it's important to point out that just for clarity, what this is basically saying is although most of us factor our landing distance, in the case of a wet landing or wet runway landing, you might actually choose, and you're likely to choose, the surface condition being wet with the landing factor being 1.0. So that's the only time that I'm aware of that we would want to factor at 1.0 with a surface condition of wet. Do you have any other times that you're aware that we would do that, Michael?
For the actual landing condition and not a dispatch scenario, I believe you're correct. Yeah, I have spoken with a couple of OEMs in the past, and it sounds like there's some struggles of theirs to teach their customers as well the appropriate setup here. We're actually working with some OEMs to try to improve this as well to make it clearer to the customer to understand what they're using here. But I would agree if you have an actual wet condition and you are allowed to use actual wet distances, you would set a wet and a factor of 1.0. That is correct. The nice thing about this too, you can very quickly compare. You can set wet with a 1.0 factor, check your distance, and then maybe you want to compare it with a 1.92 factor dry distance and then pick the longer of the two. So that is an option as well, very quickly to switch back and forth. It really depends on your operations and how you do things within your company. Beyond that, same thing. We have a weather block here, and we have an aircraft configuration section, which is, of course, specific to landing in this case. And then finally, we have the performance results, which, again, provide a little bit more information than we previously had up in the header. So we've now calculated our runway analysis, and both for takeoff and landing, and I want to direct your attention to the upper right corner. We have a summary button up there. So if I tap on that summary button in the upper right corner, what it provides me is a report page essentially for what I've just done. And it's really kind of split into two sections. This is the upper half that we see here. And we have two columns here. We have on the left, the takeoff summary, on the right, the landing summary. And below that, we have the textual engine out procedure written up here. This represents the information that you have input. So the actual weight, the actual temperature, the altimeter, all that stuff. It represents the exact setup that you have. So this allows you to print it out on a piece of paper if you want to, bring it into the cockpit. But you can also attach it to the flight. So if I tap on the upper right corner, for example, I have this send to button, I can tap on the save to flights files. And what that allows me to do is it's going to take this in PDF format and attach it to my flight, and I can access it from the flight's view. Now, the lower half of this report, it goes into a matrix setup here. And what we do is we once again have a takeoff section above and a landing section below. We essentially take, for the given runway at that airport, all the engine out procedures, as well as the straight outs and so on. And we do the analysis for all these scenarios. We have, in this case, 3 temperature rows. The 14 degrees Celsius in this case is the current temperature. And we look a little bit colder, a little bit warmer. But we do the full analysis to see, what is my maximum takeoff weight or what is my maximum landing weight and what am I limited by? So I can very quickly see if I take runway 25, I'm always obstacle limited. If I take runway 7, I'm actually thrust time limited, takeoff thrust time limited, because we do check for your 5 or 10 minute takeoff thrust time limits as well. And the bottom half here shows the exact same setup with landing. Now with landing, we show 3 rows here at your planned wind condition, but also 0 wind and 10 knot tailwind, which is the extreme and the most tailwind provided in the AFM. So we kind of want to give you an overview of what your both your actual distance or your unfactored distance as well as your factored distance look like for these different wind scenarios. Josh, is this something you refer to a lot, or do you simply stay on the actual screen and do the point calculation?
So I tend to use both views fairly equally. As you showed earlier, Michael, I do access this page prior to every departure once the takeoff and landing data has been populated in ForeFlight Mobile. And just like you showed, I put it over to the flight for archiving purposes. So essentially now that flight has my planning permanently attached to it because the flights are always accessible and the files attached to it remain accessible as well. So that's really quite handy. Prior to landing, usually prior to top of descent, I then go back into the landing data tab for the destination, and I put in the actual conditions to get not the planned performance, but the actual performance, because of course the FARs largely require us to be planned performance, but in real life, real world, I want to know what's my actual performance. So I tend to visit the landing page prior to top of descent, and then hence kind of split my usage of those 2 views.
Right. So that's going to be your time of arrival landing computation, which is, in the industry, everyone has to do it now. So it's a new, I don't know if it's a new thing or not, but everyone has to do it now. And it's a smart thing to do because you want to use the current weather conditions, current runway surface conditions, which makes sense. So it sounds like you use both of those.
Yeah, absolutely. And I think this is also a great time to, for a moment, revisit the topic of the fuel policies that we talked about. So now that we have our takeoff and landing airport and runway selected, this is where I would often choose a maximum fuel policy, because now it's going to consider weight and balance, it's going to consider my takeoff runway, it's going to consider my landing runway, as well as the conditions with those takeoffs and landings. And I'm going to get what's the absolute maximum amount of fuel that I can carry on this flight. And that's really handy for those flights where we're really having to crunch numbers. And I want to see, well, is this flight possible? And how much fuel will I have at landing if I do this flight? So it all comes together once we've input takeoff data, landing data, and go back to fuel policy with a maximum and see what do I really look like for this flight, and am I willing to depart in those conditions?
Okay, Josh, so that sounds like you're using both of those views, which is great. And you mentioned, or I actually attached the summary to this flight, and I wanted to show real quickly that's accessible. So we have these 4 buttons along the top: nav, log, briefing. In this case, we have 1 file and 0 new messages. That 1 file button, the third one from the left, if I tap on that, it's going to go into essentially a document storage area where I have all my, in this case, PDFs attached for this flight. And if I tap on that, I get the full screen view here of, in this case, my runway analysis for takeoff and landing, my summary page. What I failed to mention previously in weight and balance, a summary page exists there as well. So let me back out to flights and scroll back into the weight and balance section here. I'm going to tap on the green in balance, and it's going to take me back to my weight and balance section. And you'll note once again in the upper right corner, we have a summary button. So when I tap on that summary button, I receive a report for the weight and balance section here. And it shows me the graph on the right side. It shows me the listing of the basic operating weights items, as well as the associated values that are the weight values for each item here. And then in the lower left, we see a summary page here, and I have to scroll around a bit to make it all visible. But we see a summary page for all the basic weights and the ramp weight, zero fuel weight, and so on. Plus, we can sign it and make it official. And as you mentioned, Josh, I can send this now to the flight and retain it for archival purposes. And I assume you go through this process. Is that correct?
Yeah, I definitely do. And I have also flown with some crews that prefer to print off this summary, and that's also possible to do. So whether you are paper-based or electronic-based, this summary is a great view to come up with some really useful reports for in-cockpit as well as retention purposes.
Right, and again, this files collection section provides me all the information that I need for this flight, either during my flight or after my flight, if I have to retain it for X amount of days or months or whatever. So it's all right here, which is very handy. At this point, I'm going to switch back here to the flights view, and we've covered the weight and balance setup. We've covered the weight and balance use. We've covered the flight planning. We've covered the runway analysis. We've kind of shown how you can deep dive into the runway analysis for takeoff and landing, as well as create these summary pages, attach them to the flight. We've shown a little bit how the three components of weight and balance, runway analysis, and flight planning all talk to each other. If you're out of CG on the weight and balance side, it's gonna communicate that back to flights, and you have to make sure you get within CG. Same with any kind of weight checks and fuel checks for that matter as well. So this kind of covers the entire section of runway analysis and weight and balance, and I think I'm going to pass it back to you, Sam.
Thank you, Michael and Josh, for just a fantastic walkthrough of all of these capabilities. I think that this has been a really beneficial just tutorial on getting all of these features set up and using them in a real-life situation. All right, so before we move on to Q&A, I just want to cover a couple of wrap-up items related to Michael's presentation just now. That integrated weight and balance capability that Michael has been presenting will be available very, very soon, perhaps as soon as next week. And again, it'll be available for business performance and MFB performance customers. If you have, for example, a Business Pro subscription plan, then you will still see some of those new elements, like the ability to link weight and balance profiles to your aircraft profiles, and the weight and balance view itself will be slightly new. But the weight and balance will not be integrated with your actual flight planning unless you have, again, the business performance or MFB performance subscription plan. It will also soon be available for ForeFlight Dispatch customers, and for individual Performance Plus customers, it will be coming within the next few months. We are doing a more limited rollout to business and MFB customers first before we open it up to all individual customers. But as with business, individual Performance Plus customers will be able to access that weight and balance planning integrated with their flight planning. So that'll be coming in the near future. Runway Analysis is currently available for purchase by aircraft type in conjunction with the ForeFlight performance plans. And so you can visit foreflight.com/RWA, like Alex mentioned at the beginning of the webinar, and you can go there to see all of our supported aircraft types and purchase them via our website or by contacting ForeFlight's sales. Also, if you're planning to attend NBAA base in Las Vegas this year, I believe it starts on October 12th, you can stop by our booth at booth number 2635, and we'll provide an in-person demo of all of these capabilities, and you can chat with our sales team about getting set up with a free trial for your operation. And if you're impatient to make that happen sooner, you can just email sales@foreflight.com, and they can get the conversation started with you about setting you up with that trial and providing a live demo over the phone. So last couple things, you can watch a recording of this webinar in the next couple days. Just go to foreflight.com/on-frequency. That's where we keep all of our recordings of these on-frequency webinars. We're going to do some Q&A now. We've gotten a lot of really great questions. It was great seeing how engaged all of you are in this presentation and how excited you are about these new capabilities. So I'm just going to read through some of these questions and direct them to the appropriate person to answer. So starting at the top, how quickly are new aircraft being added? Alex, do you want to take that one?
Yeah, so we got a lot of questions about this. Generally speaking, the team's adding support for a handful, maybe 4 or 5 aircraft every single month for runway analysis. When the weight and balance solution goes live here, potentially next week, there should be weight and balance profiles available for most of the same aircraft that we're supporting with runway analysis, but there will be a wider ability to utilize the weight and balance tool and create your own profiles when that is available. We also got a lot of questions about turboprop availability, which is something that we're thinking about for 2022. Would definitely recommend you guys that are voicing support for unsupported aircraft to reach out to us at team@foreflight.com.
Awesome, thanks, Alex. Next up, similar to APG OEI procedures, is or will there be a way to see a textual bit about what those procedures are? Josh, do you want to answer that one?
Sure, Sam, thanks. So there's definitely a way to view the procedures textually as well as graphically. Like we showed in the webinar, you have a summary sheet that will list the EOP in text format. Within ForeFlight Mobile and ForeFlight Dispatch, if you're a dispatch user, we graphically depict the EOP as well. I think from a usability standpoint, it's quite nice to be able to be on the ground with ForeFlight Mobile, at the office, at FBO, etc., and be able to compare the EOP that you've selected for your runway analysis with the departure procedure that you're most likely to receive in your ATC clearance. So it's really handy to be able to have graphics and text to compare the same EOP and get an understanding for what each one entails.
Awesome. Next question. Do you have any plan to add EASA regulation as part of the runway analysis, more especially the latest LDTA mandate? Michael, do you have the answer for that one?
Yeah, sure. Thanks, Sam. Yeah, so LDTA and in context with that as well as GRF, the global reporting format to support runway CC or runway condition codes. Both of those are being supported within ForeFlight already. So for the landing distance time of arrival calculation, you can use ForeFlight and update weather during your descent for actual conditions. We do support for some aircraft runway condition codes already. That is more of a function of the manufacturer providing us data to update that with. But ForeFlight's also offline capable for all these calculations, so we fully support those requirements.
Awesome, thanks, Michael. Next up here, items in runway analysis like engine bleed always default to off. Is there any way to default those to on? And Josh, do you have the answer for that?
I do. So the answer is that yes, you can select your defaults. The defaults are primarily set from the more menu in your aircraft profile under your runway options. And as an example, in the case of the Challenger, some of the options that you can set defaults for would be whether APR is armed or not, 10th stage bleeds being open or closed, rolling takeoff, those sort of things. And of course, if you want to override those defaults on a case-by-case basis, you can also do that from the flight's view. Once you're in your takeoff or landing, once you press the takeoff or landing buttons, you're also given those same options that you can adjust.
Awesome, thank you. Next question here. Can an aircraft be set up for a group of users, or do individual users have to set up their fleet themselves? Alex, do you want to address that?
Yeah, I think just briefly for our group account holders, business performance, military flight bag performance, you can certainly create an aircraft in the ForeFlight web application and publish that to other users, and that allows you to sort of centrally manage all of those settings and push them down to the rest of the users on the account.
Yeah, that's one of the great benefits of ForeFlight's multi-pilot accounts that you definitely couldn't get just with a whole bunch of individual accounts. Next question here. The Challenger 600 series aircraft have multiple fuel tanks, each with varying moments. Does the new weight and balance capability allow for custom fuel loading of the main, auxiliary, and tail tanks and burn down for the Challenger 605 and 650? So Josh actually flies those aircraft, so I will let him answer that question.
Yeah, thanks, Sam. So obviously this is a question so-called near and dear to my heart. We absolutely support the proper burn down sequencing for the Challenger. It's something I've been using now for quite some time. It works fantastic. And it's as simple as entering the amount of fuel that you have on board, say 16,000 pounds, and it does the proper, basically proper loading between the wing tanks, the auxiliary tanks, and the tail tanks.
Awesome. And here's a question that may tie into that answer then. I have the variable fuel tables for each tank for my AFM. When I open up the fuel moment table to create a new fuel moment for each tank, it only allows one weight and moment per fuel moment and not a range. Is there any way to put a range in for each tank quantity, or does the program calculate this automatically? And Josh or Michael, whichever one of you wants to answer
I'll
that.
take that one.
Thanks, Michael.
So yeah, I don't know exactly which aircraft we're discussing here. Most likely that aircraft will be supported by our templates already, so we will have taken care of that for you. However, if you do want to completely manually set up an aircraft, you do have full control over that variability. So anything that you have in your AFM or your POH, you should be able to input it just like that into your own weight and balance model. So yes, we should be able to support that.
Great, thanks, Michael. Next up, can weight and balance be used without an internet connection? And Josh, do you want to take this one as well?
Sure. The simple answer is yes, it absolutely can. So it's fantastic to be able to be in either a non-Wi-Fi enabled airplane or outside of an FBO, hotel, etc., and be able to load up ForeFlight Mobile and do a weight and balance calculation. And it works very well, just as if you're online. You should be able to perceive essentially no difference for weight and balance calculations.
So we got a number of questions that were related to where these capabilities would be supported in terms of international flying. So this next question is, are there engine out procedures already for international mountainous airports? And Michael or Josh, yeah, go ahead, Michael.
Yeah, I'll take that one. The short answer is yes. We are expanding throughout the world globally with airport supports as well as departure supports, and we are building custom procedures definitely for mountainous airports, yes.
Awesome. Here's a bit of a regulatory question. Is this as legally binding as TERPs or PANOPS? I know APG is approved, air quotes there. Is this equally recognized? And Josh, can you answer that?
Sure, I'd be happy to. So TERPs and PANSOPs are really pretty different than Runway Analysis because they are designed for all engines operating, whereas Runway Analysis is an abnormal situation, so emergency. So is it legally binding? TERPs and PANSOPs are, legally binding in that they're two-engine normal operation procedures. However, Runway Analysis is when you've lost the one engine during takeoff, at or prior to V1, really at or after V1. And so we're not talking, apples to apples here. As far as whether Our solution is approved, or for that matter, any runway analysis solution is approved. I prefer to use the word accepted rather than approved, because it's technically and typically operator specific and up to the operator to show their POI that this is how we're doing our engine and operative procedures, and here's the results that it gives us, and do you have an issue with it? So the acceptance is something that I have experience with regards to our ForeFlight runway analysis, and I can tell you that the FSNO that I operate at has been willing to accept ForeFlight runway analysis as an equivalent solution to that which our competitors offer.
Awesome. Thanks for the clarification on that. Next question, how can this additional service be added? Is it a different subscription level or an add-on? And what's the pricing? So it depends on what you're talking about here. With Runway Analysis, that is an add-on that you need to, first of all, have a ForeFlight Performance subscription plan. And once you have that, then as part of that purchase, you can also purchase runway analysis support for certain aircraft, and that is priced by type. So for example, if you bought runway analysis for a G500, for example, then any G500s you had would be able to be used with runway analysis. So it's sold by type. The pricing is dependent on the weight class of the aircraft, and you can, if you're part of a business account, you can email our sales team to learn what that pricing is, sales@foreflight.com. And if you're an individual, there are also certain aircraft that you can buy directly through the buy page at foreflight.com/buy. Specifically, those are the aircraft that only require one pilot for those to be flown. So any of the minimum 2 crew member required aircraft, those ones are not available directly through the buy page. So you have to email the sales team. Now, that's for runway analysis. As for weight and balance, that is something that will be available for business performance and MFB performance subscription plans, possibly as early as next week. We're hoping to make this available very, very soon. And so as long as you're on one of those performance subscription plans, you don't need to do anything else. You'll just automatically have access to that, and you'll be able to go and start planning your flights with that integrated weight and balance. Now, we are hoping to make that capability available for individual Performance Plus subscribers later this year. But if you're on a business performance or MFB performance subscription plan, then there's not anything else you need to do other than just wait a few days to access the new weight and balance. Okay, next up, for runway analysis, is there an option to use forecast weather like you can with APG iPreflight? That is a fantastic feature when flight planning in advance. Josh, can you speak to how our runway analysis capability incorporates that forecast weather?
Yeah, sure. So once you set your estimated departure time, we're either going to use the TAF forecast, the MOS forecast, or a longer range forecast data. We offer the 10-day forecast within ForeFlight Mobile. And of course, you can also manually override those those pre-filled options, such as if you're leaving early morning, so it won't be as warm, or you're leaving the middle of the day. If you get into a situation where you say, hey, I think that I know this area and it's typically 15 degrees, not 20 at 7 in the morning, you can override that as well. So there's forecast data, and of course you're welcome to manually override it as well to get more specific and refined data.
Great, thanks, Josh. Next up here, some manufacturers are providing old data, OLD rather, operational landing data, in addition to the original book numbers. Bombardier recently published this new data for their CL605 aircraft. Does your performance data utilize this new old data, or does it still utilize the book numbers? Michael, do you want to answer that one?
Yeah, sure. So the short answer is yes, we do provide that if we have the data from the manufacturer. Right now, Bombardier as well as Pilatus, they're the 2 manufacturers that have provided us such data. And we have incorporated those into the PC24 model and various challengers as well. Some other manufacturers, we're still kind of waiting on that data. So it's really a function of when we get that from the manufacturers. But yes, we do turn it around pretty quickly, incorporate it, and give you the option to use the actual book data from the AFM or this operational landing data.
Great. All right. So we only have a few questions left here, and I know we're a fair bit over time, so we'll try to wrap these up pretty quickly. Can you account for MEL takeoff performance penalties by aircraft specifics, or perhaps tailor a custom section? Michael, can you address that?
Sure. So the minimum equipment list, it's something that is typically, there are a lot of variants here. So you can have all sorts of failures or abnormal conditions that affect performance. We do our best to incorporate some of those, but honestly, we do not incorporate all of them, because what we focus on is we focus on the performance section of the AFM, and anything that is published in there affecting performance, we will incorporate into our models. Now, we have received some feedback from operators saying, hey, what about this? What about that? And we have gone back into models and made the necessary options, given those options to the user as well. And then, of course, how it affects performance. So really, we do not incorporate all the MELs because there could be hundreds of different variants there, but we try to hit the big ones. And if there's a specific one that you're curious about, definitely reach out to us and we can look into adding that one in as well.
Okay, next up, what about international airports? Does your runway obstacle analysis function include worldwide destinations? What resources do you use for terrain data in those locations? So Michael, can you answer that and maybe build on the previous answer concerning global support for EOPs?
Yeah, absolutely. It's always a great question, where did the sources come from? So in terms of terrain, it's going to be the same data that I think pretty much everyone uses. We're talking the shuttle I think it's SRTM data, in addition to local surveys and things like that. Now, luckily, as a Boeing company, we have access to Jeppesen resources as well. So we rely also on Jeppesen databases for terrain and for obstacles. In addition to that, we supplement or really augment the obstacle databases based on NOTAM reports. So we continuously scan the NOTAMs and look for temporary obstacles and include that into our databases as well. But we do this globally, so no matter where you're flying, we do have that capability. And one nice thing is too is if a runway does not support a custom designed engine out procedure, at minimum we always support a straight out departure from all runways that I believe are over 3,000 feet in length and paved essentially. So there is some minimal support even at airports where we do not have a custom designed engine out procedure. And if you're looking for one, definitely reach out to us. There was another question there in terms of turnaround time. It really depends, but if you reach out to team@foreflight.com, request a departure design, we're not going to do a same day sort of turnaround, but probably within a week or so for sure.
All right, last question here. Are there plans to incorporate trim setting as provided by, for example, Guru? Michael, do you want to lead us out on that one?
Yeah, I'll take that one. It's a very popular question. We are actively working on it, and yes, that will be coming in the future. No timeline to announce, but it's definitely happening.
All right, perfect. So once again, thank you so much, everyone, for attending and sticking through to the Q&A. Again, it was really great seeing how engaged all of you were and how many great questions were being asked here. There is a very short survey that will pop up on your screen right when I close this. So if you don't mind sticking around for just 2 more minutes to answer that. In fact, it'll probably only take you 30 seconds. So again, with all of these resources on the screen, if you're interested in learning more about runway analysis, just foreflight.com/RWA. If you are going to be attending NBAA in Las Vegas, you can stop by booth 2635 to see us. We also have a number of presentations at the show. Both Michael and a few other people, including myself, will be giving presentations. So you can definitely learn more about these capabilities there. We will have a recording of this webinar up on foreflight.com/onfrequency, hopefully later today. So you can share that around with your friends and anyone else who would benefit from all of this great information. And if you want to, as we've been saying throughout this whole Q&A, anytime you have a request or something you need to know that you're not sure about, you can email team@foreflight.com. And especially if you're part of a business account and you're interested in demoing runway analysis or learning more about weight and balance, or just getting a sense of what's coming in the ForeFlight product pipeline, because there's always lots of stuff, you can email sales@foreflight.com and set up a call with our sales team. So once again, thank you so much, everyone, and we'll see you on the next webinar.